are independent, then the probability of A and B happening is equal to the probability of A times the probability of B. That is the independence rule that you have to know. If I want to roll a 4, that's a 1 out of 6 chance. If I want to get a sum that is 7, as we know from one of the first ones, there are 6 occurrences of getting a sum of 7. That's all of them. A 1 and a 6, a 2 and a 5, all the way to a 6 and a 1. That's 6 out of the 36 chances, which is 1 out of 6. So probability of A times the probability of B is 1/6 times 1/6, which is 1 over 36. Now, I need to show that I know, what the outcome of A and B is. So the probability of A and B, I need to show what that is. So I need A to happen. I need to roll a 4. And then I need B to happen. I need to get a sum of 7. The only way to get that is to roll a 4 and then a 3. That's 1 out of 36, and they equal. That's true. So it's yes, they are independent. All right, take a look at this one right here. An odd number coming up. That's 3 out of the 6, 1/2. The sum is odd. That's 1/2, 18 of the 36. 1/2 times 1/2 is 1/4 on this right side. So I need to know the probability of A and B happening. Again, because I don't know that this is true, I got to show that this is true. You can't just assume it. So an odd number on the first roll, and then getting a sum that's odd. That's getting a 1 and a 2, a 1 and a 4, a 1 and a 6. I could also get a 3 and a 2, a 3 and a 4, a 3 and a 6, and then finally a 5, 2, a 5, 4, 5, 6. That's 9 out of the 36. 1/4. OMGs, 1/4 is 1/4. They're independent. Folks, if I have a probability of success of 0.55, and I'm going to do this 4 times, and just one of them has to succeed, then I need to do 1 minus the probability of total failure. It failing has a probability of 0.45. I need to fail 4 straight times. So 1 minus that, basically 96% chance at least one of them is going to work. To figure out your vote, take 0.53 times 0.45 plus 0.36 times 0.57, and then plus 0.11 times 0.35. All right, 48.22% of the vote they should expect to get. All right, folks, we've seen this one before. What's the probability that they have less than a high school diploma, given that they're unemployed? So unemployed less than high school diploma divided by the total unemployed. Guys, at least the high school diploma means everything but less than that. So you take everything and you subtract those that don't have a high school diploma. That's this many, and divide it by the total number of people employed. All right, what is the unemployment rate for those individuals who have less than a high school diploma? So you take those that are unemployed divided by the total number of them. Unemployment rate is written as a percentage. What is the unemployment rate for those individuals who have a bachelor's degree or higher? So for bachelor's degree or higher, you take the unemployed divided by the total. All right. What percent of the eligible workers, so that's everybody that's employed and unemployed, had a bachelor's degree or higher? So you take all of them, the 40,000 plus divided by the 125,000 plus. There again, that's in terms of 1,000, so that's actually over a million. Okay. 32.3% of the population eligible to work had a bachelor's degree in 04. And then what percent of workers had a high school diploma or less? That's 2 categories. That means they have a high school diploma, they're a high school grad with no college, and they have less than that. So you need to add those up and divide by the 125, 133. Okay, again, conditional probability here, folks, not difficult. Those are not hard questions. And folks, moving on, almost done with these. Let's take a look. You've applied to both WashU and Stanford, so in the middle, put the probability that you get admitted to both, then subtract that from the probability you get into WashU. You have a 17% chance of only getting into WashU. Same thing for Stanford, do 0.54 to minus 0.29. Add these up and subtract from 1, a 29% chance none of them admits you. I want to get into at least one of these 2 schools, so I need to add in that, and the probability I get into both. At least one means 1 or 2. What's the probability only WashU admits you, only Stanford admits you? Not tough, folks. We want to get that one right for sure. All right, this next one. All right, so the probability I get into all three schools goes in the middle. Probability of A and C happening, A and B happening, B and C happening, and then subtract. Add those up, subtract from the probability of A. That's the probability of only getting into MIT. Probability of only getting into Vanderbilt. So add this, subtracted from 5.4. Add this, subtracted from 5.9. Okay, and then those are our answers. Add all those numbers up, subtract from 1.16, so 16% chance I get into none of those schools. Guys, at least 2 means 2, 2, 2, or the possibility I get into all 3. At least 2 means 2 or 3 schools. Okay, what's the probability I get in at least 1? I can do 1 minus the probability of getting into none of them, or I can just add all those up, 0.84. All right. Look at that, folks. Our last question. 183 underclassmen math majors were asked whether they took taken Calc 1 or Calc 2 or possibly both. 107 took both, so you do 118 minus 107. Only 11 took Calc 1. Then you do 161 minus 107. 54 had only taken Calc 2. Add those up, subtract from 183. 11 math majors had not taken Calc 1 or 2 in the last year, okay? If I want to find the probability that a student has only taken Calc 2, I divide 184 divided by the total population. Only taken Calc 1, do 11 divided by 183, and had taken neither is first, and then Calc 1. Anyway, it has the same answer there. That is coincidence. Okay, don't expect that to happen again. All right, folks, so this is Yak Math Videos with your Stats Exam 3 review video, signing out.